So we are asked which of the following are equivalent to 9 times 9 to the 5th. Well, the 9 times 9 to the 5th is the product property because we are multiplying two things with the same base, which means we can add their exponents. Now remember, this first 9 actually has an imaginary exponent of 1. So when I add those exponents, I'll get 9 to the 6th. So I'm trying to see which ones will actually equal 9 to the 6th. So if I look, the first one is the power property. So I have 9 to the 3rd all being taken up to the 2nd power. Remember, power property says that I can multiply my exponents. So this would be 9 to the 6th. So it is equivalent. The second part is adding these two bases. We do not have a property for adding two things with the same base. So I did prove, though, that it is not equivalent because 9 to the 6th, which is 9 times itself 6 times, is equal to this fairly large number of 531,441. If I actually work out what 9 squared plus what 9 to the 3rd is, it actually gives me 810, nowhere close to the 531,441 that 9 to the 6th actually is equal to. The next one is the product property. 9 to the 3rd times 9 to the 2nd will give me 9 to the 5th, which is not equal to 9 to the 6th, so it is not equivalent. So then D is our quotient property, which says that if we are dividing two things with the same base, we will subtract their exponents. Be careful on this one, though, because when you subtract the exponents, you will get 4 minus a negative 2. Remember, that is a double negative, which will make it a positive. So it'll be the same thing as 4 plus 2 to give you that exponent of 6. So you were asked to figure out which expressions were equivalent to 5 to the 7th times 5. 5 to the 7th times 5 is equal to 5 to the 8th because the exponents of 7 and 1 together will give us 8. So choice A is the product property, so I'm going to add the exponents and get 5 to the 8th, which is equivalent. B is the quotient property, so I'm going to subtract the exponents because their bases are being divided. 11 minus 3 is equal to 8, so B is also 5 to the 8th. Remember, there is no property for addition, so C is going to be incorrect because there's no way to combine those. And then D, we have the power property. If I multiply those exponents, I'm going to get 5 to the 15th, which is not equivalent. Now the next thing is you're going to look at this problem. It's asking whether these are actually equal. So 4 times 4 squared is equal to 4 times 4 to the, 4 times 1 over 4 to the negative 2. Now, I'm not sure why there's an extra set of parentheses there, but there it is. Right. So if you look, they both have a 4 out front. That part's the same. So the difference that we're really looking at is 4 squared, if that's actually equal to 1 over 4 to the negative 2. Now remember, to change negative exponents, what we're going to do is we are going to take the reciprocal, which means to flip our fraction. So we are going to take 1 over 4 to the negative 2. We're going to do the reciprocal, which gives us 4 to the 2nd over 1. Remember, once you take that reciprocal, that's when the exponent becomes positive. And remember that anything divided by 1 is just itself. So, in fact, 4 squared is the same thing as 1 over 4 to the negative 2. So they are the same. They are actually going to be equal. So the answer is yes, they are equal. All right, so you were asked whether 1 over 3 to the negative 7th is equal to 3 to the 7th. You should have said yes, because in order to change a negative exponent into a positive exponent, we are going to take the reciprocal, which means to flip the fraction, and then change the exponent to positive. So you would get 3 to the 7th over 1, and anything divided by 1 is itself. So the next question we're looking at is 5 to the 4th times 3 to the 4th, what that is actually equal to. It is going to be equal to 15 to the 4th. So this one is actually the power property kind of in disguise. So what I can do, because they have the same exponent, I can group the bases together and put them to the same exponent. So I have 5 times 3 in parentheses up to the 4th. Remember, I could distribute that 4 to every exponent and get back to my original problem. Well, 5 times 3 is 15, so this would be the same as 15 to the 4th. You could also group them. 5 to the 4th means 5 times itself 4 times. 3 to the 4th is 3 times itself 4 times. I could group a 5 and a 3 together 4 times to get 15 4 times, or 15 to the 4th. So you were asked if 9 squared times 4 to the second is equal to 36 to the second, and this is true. Because the exponents are the same, we can group the bases together under the same exponent. Right? So I can group 9 and 4 together and make it squared. Well, 9 times 4 is 36, so this is the same as 36 squared. Right, so this table shows the salaries for some players for the New York Knicks in 2013. So the first question asked me about Tyson Chandler's salaries. That's right here. If you notice, they wrote it a little bit weird as $14.1 million. Now, 1 million is the same thing as a 1 with 6 zeros, or 1 times 10 to the 6th. So 14.1 million is the same thing as 14.1 times 10 to the 6th. Now, for it to be in scientific notation, I need to adjust this. The 14.1 is too big for my mantissa because it is not between 1 and 10. So I'm going to need to move this decimal place once to the left, making my mantissa smaller, so it's between 1 and 10. Now, when I do that, I moved it 1 decimal place smaller for my mantissa. My exponent needs to adjust to make up for that. So since my mantissa got smaller by 1, my exponent will get larger by 1, and I need to make sure to include the dollar sign because we are talking about money. So on the one you were asked to do, you were looking at Carmelo Anthony. Carmelo Anthony makes $21.4 million. Remember, a million is times 10 to the 6th. So that's 21.4 times 10 to the 6th. 21.4 is too big for your mantissa, so you need to move it 1 decimal place smaller. And when you move that 1 decimal place smaller, your exponent will have to get 1 decimal place bigger. So it'll change from 6 to 7. This next problem has 2 different ways to answer it, and it is completely up to you which one you prefer. You can either take all the numbers into standard notation, or you can take them all into scientific notation to make it easier. Because more of them are decimals, I probably would have done it only by standard if I was just doing it for me. But since I was doing it for you, I did it for both. So the answers are here in the middle. It's from greatest to least. 1.8 is our biggest number. If you notice in standard notation, I kept the decimals lined up as best I could when I was writing it. Since 1.8 is the only one that has anything in the ones place, it is the biggest number. And then I would compare the tenths place. If you notice 0.18, the only thing that has a non-thing, anything other than 0, other than the one we know is already biggest. And then we just keep comparing the next decimal places to figure out which one is basically not 0, okay, of the ones that are remaining. If you're looking at scientific notation, it's actually really easy because you're just looking at the exponents. The exponents need to go in order from biggest exponent to smallest exponent. Now, since we're talking about negatives, it means the closest to 0 for the exponent and the farthest away from 0 for the least. Okay, so it's up to you which way you decided to work it out, but either way, you will get the same answer. Just like the last one, there are 2 ways to get your answer. So if I look, 2.7 is the largest one, no matter whether I did it in standard or scientific notation. So it's either going to be A or B, which means C and D cannot even be. So I'm not even going to check any further than that. Actually, even A is not. I read it wrong. So it has to be B. So it has to be B. But we're going to double check, okay? If we look at our standard notations, you'll notice that basically the numbers are actually getting farther and farther into the decimal as it goes down. So those places are getting farther out as we go down. If we look at the scientific notation, our exponents are going farther away from 0, so they're getting further negative, and therefore they are getting smaller. So you can choose whether you want to make it standard notation or scientific, but either way you will get the same answer, which was B. Alright, our next problem is a word problem. So it says, in one day, Fox had 1.6 times 10 to the 6th viewers, and TBS had 5.2 times 10 to the 5th viewers. How many viewers did the channels have combined? Now remember, combined means together, so that would be adding. Now in order to add, you need to have the same exponent. So I'm going to match this higher exponent of 6. So if I change this exponent from a 5 to a 6, that is going to make it where my mantissa needs to get smaller. So my exponent got bigger by 1. My mantissa will need to get smaller by 1 place value. So I changed my mantissa to 0.52. So then I'm going to add my mantises together. So 1.6 plus 0.52 is going to give me 2.12, which becomes my new mantissa. And then the 10 to the 6th, which I matched at the very beginning, becomes my new exponent. And remember, we are talking about viewers, so it's 2.12 times 10 to the 6th viewers. On the next problem, we're talking about in 2012, New York City and Los Angeles had the highest populations of any cities in the U.S. So New York City's population was about 8.1 times 10 to the 7th, and LA's population was about 3.8 times 10 to the 6th. So I want to know what the population of these two cities is combined. Again, combined means adding. So I need to get my exponents the same before I can add. So I'm going to match the higher exponent, which is 7. So I need to change this 6 to a 7. It's going to go up by 1. So that means my mantissa needs to go down by 1 place value. So I get 0.38. Then I'm going to end up adding my mantisses together, which will give me 8.1 plus 0.38, which gives me 8.48. And then I'm going to keep my highest exponent, which was 10 to the 7th. And remember, we are talking about population, so it is people we are talking about. Okay. So then our next one, we've got students at Salt Lake Community College pay 1.5 times 10 to the 4th dollars for tuition. Students at George Washington University pay 4.2 times 10 to the 5th dollars. How many times greater is the tuition at George Washington? Now remember, if it's asking how many times something is happening, how many times greater, how many times smaller, it is going to be division, okay? Because we're trying to figure out what we're multiplying by, so it's the opposite. So it says times greater, so I'm going to put the greater number on top. I'm going to divide my mantisses to get 2.8. I'm going to end up subtracting my exponents because their quotient property tells me when I'm dividing two things with the same base, I should subtract my exponents to get 10 to the 1st. So it is 2.8 times 10 to the 1st times greater. So basically it is 28 times greater. The state of Colorado covers about 1.04 times 10 to the 5th square miles. The Indian Ocean covers about 2.808 times 10 to the 7th square miles. How many times bigger than Colorado is the Indian Ocean? So we're going to put our larger number on top. We are going to divide, because it asks how many times bigger, by the smaller number. We divide our mantisses to get 2.7. We end up dividing our 2 powers of 10 and subtracting our exponents to get 10 to the 2nd. So it is 2.7 times 10 to the 2nd times bigger, which is the same thing as 270 times bigger. All right, our next problem says an Amazon warehouse carries on average of 7.2 times 10 to the 9th items in stock. If there are 1.2 times 10 to the 3rd warehouses worldwide, how many items do they carry in all? So because we're talking about how many times this is happening worldwide, we're talking about multiplication. So we're going to multiply these by multiplying our mantisses, so 7.2 times 1.5 to get 8.64. We're going to end up adding our exponents to get 10 to the 12th, so it's 8.64 times 10 to the 12th items. And our final question says the U.S. spends 1.05 times 10 to the 4th dollars for each student every year. If there are 7.7 times 10 to the 7th students in the U.S., how much do they spend in all? So because it's happening over and over and over again, it tells me it is multiplication. So I'm going to multiply my mantisses of 1.05 and 7.7 to get 8.085. I'm going to end up adding my exponents for my powers of 10 to get 10 to the 11th. If I put those two together, I get 8.085 times 10 to the 11th dollars.